Hey everybody, welcome to the Automation Podcast. My name is Shawn, and this week on the show, I interviewed George Konidaris from Realtime Robotics. Now that name may sound familiar. We covered them several weeks back on the Automation Morning Show. They had a press release where they announced that they released technology that allows multiple robots to work in the same workspace. So I thought that was really cool. I reached out to the company and George graciously agreed to come on the show and be interviewed. Now, with that said, I do want to give a shout out to our sponsor. Each of these episodes takes between 6 and 10 hours to produce. And of course, our people don't work for free. So it's sponsors like the automationschool.com that make this show possible. So if you know anybody who needs PLC, HMI, or SCADA training, please send them over to our sponsor's website, theautomationschool.com. And with that said, let's go ahead and jump right into this week's episode. George, thank you for coming on the Automation Podcast. Really appreciate you taking time out of your busy day to come on to bring us up to speed on technologies. But before we get into what you're going to talk about, first, could you take a moment to introduce yourself to our audience?
Thanks, Shawn, and thanks so much for having me on. It's a great pleasure to be here and get to talk to all of your listeners. So my name is George Konidaris. I have two hats. I wear two hats in my life. One of them is that I'm an associate professor of computer science at Brown, where I do robotics and artificial intelligence research. So I write academic papers, I build demo systems, and I try to understand how to make robots smart in the kind of long range version of smart. Like how do we build generally intelligent robots? And then my other hat is that I'm the chief roboticist of Realtime Robotics, which is a technology startup based in Boston, founded around some technology that me and some of my colleagues designed that allows robots to do automated motion planning. So maybe I can explain a little bit about what automated motion planning is. So when you're a robot, as you and I sort of are, you can think of yourself as being in a pose, like your body is in a particular set of joint values. And very often you'd like to move to another pose. For example, if you want to pick up this mug, you might want to move from where you start to the position in which you can grasp the mug. And you'd like to be able to generate a motion through space that moves your arm through space from where it started, the pose in which you start to the pose in which you can grasp the mug. And that's actually been the subject of, like, at this point, 40 years of research in academic robotics, is how you do that computationally efficiently without colliding with the world around you. It turns out that the vast majority of paths that you could take land up in a collision. If you think about reaching into your fridge to grab a beer, and you imagine that you have a robot arm, like a 6 or a 7 degree of freedom arm, and you're controlling it with a joystick, actually, the vast majority of choices you can make will lead you into crashing into something else in the fridge or the door or one of the shelves or something like that. Actually, it's a very small set of paths that get you where you want to go. And our technology enables robots to compute those on their own, the same way that you or I just generate motion without thinking about it. Right? We never think about where to put our elbow exactly when we're reaching into the fridge. We decide where we want to put our hand, and the rest of the stuff gets computed. And one of the things that I'm most excited about is how that's going to change the game in industrial automation. At the moment, if you want to automate something with a robot, you essentially have to, manually pre-program that robot's entire motion. A human has to do the thinking for the robot about its basic spatial awareness and how it moves through the world. And we're changing that. We're going to get it to the point where the robot has a couple of layers of basic physical intelligence, can move around the world by itself, even in the presence of other robots, in the presence of moving obstacles, in the presence of unmodeled obstacles, and just be able to move around without hitting stuff. It's, just as basic as that could actually change the way that automation happens today. Does that make sense?
No, it makes a lot of sense. And I think the article I had brought up on our morning news show, was where there was two robot arms working very closely together. And, there's a thing there where if they're both pulling parts out of the same bin, a lot of times people just default that if he's in the area, he doesn't move. And if he's in the area and he doesn't move, and that we know could be very wasteful as far as efficiencies, because it would be great if they could, one was leaving, the other one can go in, and there could be a lot of efficiencies there. So please continue on with what you guys are doing.
Yeah. So that's actually one of our most, I think of that as our sort of first killer app, which is, it's the case that very often you want multiple robots in the same work cell or in the same workspace. But as you say, the way that we program that today is that you set up these interlocks where only one robot is allowed in a volume of space at the same time. And a human does all the coordination in advance, does all of that work, and then kind of watches it happen a couple times and inevitably is conservative about how the robots can move, because you're not going to be there at runtime, and there's always going to be some process variation. And so what we find is that typically when you deploy 2 robots, you only get like a 25% throughput boost in something like pick and place, right? You aren't moving twice as much merchandise in the same amount of time. You're moving 1.25 times as much merchandise, because the robots have to wait for each other in this conservative way. But with our system...
Okay, I'm going to just pause the podcast here for a moment to thank our sponsor for this week's episode, theautomationschool.com. If you know anybody who needs PLC, HMI, or SCADA training, please send them over to our sponsor's website, theautomationschool.com. And now back to the show.
But with our system, you just plug all the robots into the same box, and they can very finely move around each other, choosing their motions at runtime. What they actually do is they kind of reserve a little bit of space ahead of time. So the one robot sort of decides where it's going to go and reserves that motion through space. And then the second robot treats that as an obstacle to avoid. And we found that it can be more like 1.75 times the throughput. So there's a lot retrieved there. But what's even more exciting is you don't have to stop at 2 robots, right? We can support up to 16 in the same workspace. And so there's lots of automation tasks. Automotive is the most common one, where you want to maybe weld or put in bolts all over a car chassis, and there's a lot of holes and a lot of welds you want to make, and moving the chassis around is very expensive, takes a lot of time. So it'd be great to have just 12 robots working at the same time, and we can do that seamlessly without any effort on the designer's part.
So, I mean, that as a concept and as a solution, it sounds excellent, right? So what is the company, though? So the company, what does it, give us the name of the company again.
So it's Realtime Robotics.
Yes. And so what do they sell? Do they sell a software package, integration services? Tell me about, let's say somebody's listening to this and they got a bunch of cobots and robots and they're like, we need this. What would be a deliverable from your company?
So we sell sort of 3 products at the moment, and eventually we're going to expand to cover all of the kind of avenues into automation. But at the moment, there's what we call the real-time controller, or the rapid plan controller, which is a box that you plug your robot into, and that you issue commands to. So very often customers are programming the sort of logic of their work cell using a PLC. We give you a slightly different command set that reduces PLC program lengths from hundreds of statements to tens of statements. But that goes through that controller box, right? So we're sort of like a layer of abstraction at runtime over the robot. And then we have a Rapid Plan Create, which lets you design your work cell and decide where the robot should be moving. So you can import a CAD model, input all the sort of static obstacles, like, this is where all the walls are going to be. These are the areas in which the robot should have coverage, and we kind of pre-compute a bunch of stuff that allows us to do that efficiently. And then there's Rapid Sense, which, if you have unmodeled obstacles, like, for example, boxes are just going to get thrown into the work cell and you're not exactly sure where, you can set up a bunch of cameras and we will detect those and motion plan around them.
Okay.
So it goes all the way from that kind of design software down to the thing that runs the robot at runtime.
Absolutely, yeah, that sounds great. And interesting you use the word motion plan. I know with the Rockwell motion controllers, their servo controllers, they actually call part of the system the motion planner, and the CPU does all the planning up ahead of time, and it sends parts of it out to the servo drive and then waits for feedback to see how it has to autocorrect, and maybe it needs more torque, maybe it needs less, so that's very interesting. Now when you could you talk to us about an application maybe that you've used this on over the last year or two?
Sure, yeah. So one of them, actually, the majority of our customers at the moment are in automotive.
Yeah, sure.
So in one example, I'm trying to remember if I'm allowed to say the name of the customer. I am allowed to say that we have worked with BMW. I think that's public.
Okay.
So let's say in one particular example, you want to take a car that's been welded and you want to do a bunch of scans around the car just to make sure,
Sure.
like CT scan type things, just to make sure that everything was solid.
Yeah.
And that requires something like a couple of hundred particular poses that the robot needs to be in order to do the scanning. So you could sit there and you could manually design the motion of the robot through space. Go here. Move your elbow this way so you don't hit the car chassis. Now, move the robot like this. With our thing, you just give the endpoints, and then you ask it to compute a sequence of paths, and you can put as many robots as you want in, and it will just automatically decide how to move through space without colliding. So in that case, we reduced the time to design the system from many, many weeks down to like 1 week,
Yeah, I
which
can
is exciting.
imagine with multiple robots, you could get that scanning done a lot quicker too.
Yes. Yeah, and it's the engineering time and it's the throughput. Both of those are reduced.
Yep.
We've had other cases where we do pick and place, where there's multiple robots, as you said, in the same workspace.
Yep.
So you can clear out a bin of parts much faster. We've done a bunch of spot welding, where you bring a car chassis or like, let's say the like a large, I forgot the large metal piece that runs along the base. What that's called. It's the bottom of the base plate, basically. It has, there's a bunch of welding that you have to be able to do, and you want to employ many robots to be able to do that. And instead of having to manually coordinate everything by hand, you just tell us where you want the welding to happen. You kind of tell us where the business end of the robot needs to go, and we'll take care of everything else. And so there, we've drastically reduced the amount of time required to get the system up and running.
Now, as far as robot manufacturers, is there any limit of like which ones you can work with?
No. So what we end up doing is we end up writing basically robot drivers for every manufacturer, and then every family of robots in that manufacturer. And there are various stages of completion, but we're going to get to the point where all of them are there and highly performant, which is exciting, because then the automotive, the integrator doesn't have to think about the details of any particular robot programming language. For example, you don't need to worry about, if you are programming a Mitsubishi, you need to use Alpha Basic, or if you're programming a FANUC, there's a different language. All of those things just plug into our system, and we take care of the high performance control. So I often liken this as to a printer driver. One way, when we do automation today, when we do integration today, it's like, if you wanted to use an HP printer, you'd have to use a different programming language to a Lexmark printer. Like, that's crazy. Why would you ever do that? Of course, you would just install a printer driver. And using a robot arm today is like that sort of almost pre-DOS level of automation. You have to know all the details of all these very vendor-specific things, which just locks you in, right, and makes you less productive. And so we want to sweep all that away.
Yeah, it's I was just talking about this in today's show that we released today. Of course, we're recording this when we're not live, but today's show I was talking about back in the day, in the years era of DOS. It was so frustrating because with printers, because like if you bought Microsoft Word, you could only use whatever printers it had drivers for. And it was a very frustrating time. So for those who don't know, and I'm no robot expert myself, but each robot manufacturer has like their own programming language for their robot. And so it's not as simple as just providing it with a pulse train or an analog signal. And so your interface, and now if we talk about the other side, so that's the robot side, let's talk about the other side. How do you interface to automation systems?
So what we normally do is, for example, we expose a PLC instruction set. So very often someone will control a work cell using a PLC, and then we just provide them with a set of commands, typically over something like industrial Ethernet, that they can command, and then the integrator builds the rest of the cell, coordinates all that stuff, and they just send much simpler commands to the robot, right? The way to think about it is, we're really raising the level of abstraction at which you need to communicate with the robot. You need to think about much less. You really just need to think about the business end and what it needs to be doing, instead of the whole robot's body, which for a 6 or 7 degree of freedom arm is a lot to think about.
Yeah, a lot to think about and control too. Yeah, we have a lot of PLC programmers in the audience, a lot of Rockwell PLC programmers, a lot of Siemens and Mitsubishi, and I won't go through all the products behind me, but in any case, so it's typically an industrial Ethernet connection, whether it be Ethernet IP or Profinet or one of those that you support.
Yes.
Okay.
Yep.
Yeah.
And
excellent.
yeah, and our goal is to kind of meet integrators where they're at. So if it turns out that we don't have something that you need, you let us know. We'll build it in.
And I think
But
that's
our
a good
goal is
good
really to
point
make your
too.
life easier.
So you typically work with integration firms because I know a lot of integration firms over the years have taken on robotics as a big part of their. So you may have had an integration firm that did general wiring, that did control panels, that did PLC and process control. And over the last 20 years, they've taken on robots, whether it be Fanuc or, Universal Robots, Locus Robots, ABB, whoever. They've taken
Mm.
that on as a line, and I know
Yep.
I left some robot companies out, Mitsubishi and others. But so you work a lot with these robot integrators to implement
Yeah.
your solution?
And we'll get back to that in one moment. But first, I want to talk about our featured product from our sponsor this week. It's the S7 PLC Level 1 course from the automationschool.com. I know of a lot of you have already mastered Allen Bradley PLCs, and I know the Automation School has mostly Allen Bradley courses. But if you would like to master the S7 PLCs from Siemens, then I highly recommend you check out their course. They just added a bunch of new exercises. They got new lessons coming over the coming weeks. And it's over a 10-hour course that you get lifetime access to when you sign up, lifetime support as well. And it's the only course you will find anywhere in the world that comes with 7 hours of interviews with Siemens experts. That's right, included free with the course in the bonus section are several hours of interviews with experts right from Siemens themselves. So if you're interested, please check it out over at theautomationschool.com. And with that, let's jump back into the show.
Yeah, our ultimate goal is to make their lives easier, right? Because mostly they're building the work cells. And so the question is, where are they spending their time? And ideally, you want them to be spending their time thinking about the sort of business logic of that particular work cell, right? What is it about that particular work piece that needs to be, needs a specific process? But instead, they spend most of their time thinking about the details of a robot that don't actually, just moving it around.
Yeah. Yeah.
And that's not the best use of anyone's time. It's not the most productive way to think about things. And candidly, we're doing that because today robots are just really stupid, right? Like you have to do all this thinking in advance for the robot because it's so dumb. And by trying to make it just a little smarter, just able to move around in the world without hitting stuff, without hitting other robots that are connected to the same box, it turns out that you can remove most of that complexity and get some performance win in return.
Now, I do want to get to literature you have available, your website, videos, and whatnot. But before we go there, we've covered a lot of ground here. But is there anything that you wanted to cover that we didn't talk about?
No, I think it's just, I think what I want to say to people is, I'm a tremendous admirer of what people are able to do in automation. I think it's like a modern miracle. I often talk about how my car I drive a Toyota Camry, and for what you get, it's amazing that you can buy something with a lifetime drivetrain warranty. It's just like a complete miracle of modern automation. But I think we've also been doing the things the same way for a long time.
Yeah.
And we've been doing it that way because they work, and also because a lot of the burden on making them work and making them efficient and getting the ROI good is kind of on us. But I think there's a route now through technology to be able to break out of the box of what can be efficiently automated, what can be profitably automated, and make it much wider if we're able to offload some of that cognitive load onto a machine, which should be doing the work anyway. So I'm hoping that people will be willing to take a bit of a risk and start to think about automating a wider class of systems. I think that would be really exciting.
Yeah, I'm definitely seeing, we had recently had a vision camera company on, and just looking at what they're doing today with the machine learning and what we had to do 30 years ago. It just, you're finally using the power we have in these small chipsets to do things that we could never have done. We basically had to set up all the tools manually back in the day, and it was very sensitive to lighting. And now, especially because of the, smartphones and all the technology there, and faster, smaller, cheaper, better, especially when it comes to cameras and other, sensors. We're really seeing, I think, an explosion of new applications, and you guys with your application is solves one piece of that complexity with robots to make them much more efficient, which is very very cool. But before we close out here, I would like to know, and we do have about a quarter of our audience is listening as they're driving or walking the dog or whatever. Could you tell the audience what your website is and tell us a little bit about what's available there and maybe on your social media channels?
Sure, yeah. So our website is RTR.ai, so Real-Time Robotics, just the initials, .ai, because we're an intelligence company. And you can go there and you can watch a couple of videos of robots moving around and a couple of case studies of things we've automated. And you can get in touch with us if you're interested in demoing a product. We are in Boston. You are always welcome to drop by our offices too. We have lots of robots. I have this, I don't know if this makes you quite as happy as it makes me, but in our offices, you can always hear the robots whirring in the background, large numbers of robots whirring in the background. Makes me very happy. So go to our website, have a look. We have a bunch of videos. I think we're most active on LinkedIn, which is sort of not very, I guess it feels kind of businessy as a social media platform, but we have lots of things posted on LinkedIn, and there we're just listed as Real-Time Robotics Inc.
Yeah, and I think that's good. We just see most LinkedIn gets 90% of all the activity for us on social
Mm-hmm.
media. It is just where industrial automation lives, I think, on social media compared to the other ones, it's not even close. So I'm
Yeah.
not surprised by that. I do got to take a tour of all the Boston companies. Having myself being here in the Berkshires now, the wife and I do plan on moving someplace a little bit warmer, a little farther down the Appalachian Trail. But before I go, I'm going to have to make sure I come out and see you guys. And there's so many other great companies in the Boston area. So we'll definitely have to take a reading check and do that here in the coming months. But
Yeah, that'd be lovely.
yeah, George, I really appreciate you coming on the show and telling us about your company, telling us about this exciting technology. And I want to encourage any of you integrators out there who are listening or watching, if this sounds like something that could help you make your deployments more efficient and more profitable for your end users, reach out to them and give them a buzz. But with that, any final words, George, before we let you go?
No, I just wanted to say, if you're out in the Berkshires, I did my PhD out in Amherst in Western Mass, so I imagine that you have beautiful views. It's a lovely part of the world.
Yeah, a lot of Allen Bradley PLCs out there. I know the integrator who did a lot of that work. So in any case, we don't actually consider Amherst the Berkshires. So
Oh, we don't. Okay, all right. You can see the Berkshires from Amherst. Maybe
oh,
that's.
absolutely, you definitely can. Yeah, you definitely they're right over the line. So, but in any case, it's still a great place. Judge, I want to thank you very much for coming on the show and taking time out of your busy day to talk to us about your product.
Great. Thank you so much, Shawn. It's a great pleasure.
Well, I hope you enjoyed that episode, and I want to thank George for coming on the show and letting me interview him about real-time robotics. Now, if you did enjoy this episode, please consider giving us a like and a sub. And if you want to follow me or get in touch, you can do so over at automation.locals.com. That said, you'll also find all of my training courses over at this week's sponsor's website, theautomationschool.com. With that said, I want to wish you all a very happy, safe, and healthy week. And until next time, my friends, peace.